Isn't that the first thing you think of? Okay, 50. Sorry. Oh, 50. Guess what kind of problem this one is? Is this just like the one we just did? Yep, it's one of those souped up difference of squares, okay? Here we go. It's just got that rational expression there. What's going to go here in the first spots in each set of parentheses? Somebody talk to me, come on. Thank you. 1 plus 1 over x. 1 plus 1 over x. What's going to go in the second spot in each set of parentheses? 1 minus. And then my signs in the middle are going to be what? Different. Because it's just a fancy difference of squares. Now, I got my minus sign in the front this time. All I'm going to do is do what with that negative? Distribute. So I'm going to rewrite 1 plus 1 over x minus 1 plus 1 over x. And then we're going to combine like terms. Folks, the problem's up here. It's not on the side of the wall. Just saying. 1 plus 1 is 2. What happens to 1 over x this time? Cancels out. It's 0. So is it okay for me to just have a plain old 2 there? Yeah. And now, I'm going to combine like terms again. Now, the 1 over x thing will mess with your head. Okay? Bless you. Because you're like, oh, what in the world? What happens to the 1s, the plain old 1s? They cancel out. But then what about that 1 over x plus 1 over x? I had to think about this. 1 over x plus 1 over x. Isn't this just adding fractions? Yes. So our denominators have to be what when we add fractions? The same. Are they the same? So what do we just do? Add across the top, and it gives us 2 over x. It's still weird. It looks weird. That is messed up. But that's what it is. 2 over x times 2. Can I rewrite 2 as 2 over 1? And now we're multiplying fractions, and what do you get? 2 times 2 is 4. X times 1 is x. Shamalama ding dong. How about that? Bringing it back. That's what y'all need to say. Y'all don't need to curse. You need to say these crazy things. Shamalama ding dong. See what people say. Dare you. Dare you. Questions? Is it better seeing this now? Do you feel better about this? Yeah? It is not that difficult, promise. Okay? What was next? All right, so we've done 50. Go to, oh, did we do 49? And we just did 50, right? 59, 60. All right, 59 and 60. 59. Oh, 59. I like 59. We've had the tree and forest discussion in here, and most of you know what I'm talking about when I say the forest and the trees, okay? I am typically a tree person. I get hung up in the details. If it's a whole lot of stuff going on, I kind of just go, and then I want to go all algebra. Do this, do this, do this, do this, do this, do this. Add, combine like terms, and it's just crazy, okay? But I told Dr. G this morning, I said, you'd be proud of me, because the very first thing I see when I see this is I'm standing back looking at the big picture, and I can go forest on this. I do not want to distribute and then have to factor or multiply. This is crazy. All right, so step back and look at the big picture. This is like having a grouping problem like the first line of a grouping problem. You have the grouping problem, and then you have your first line of work. Now, I want you to look at it. What's the first thing you factor out always, if possible? What's the first thing? GCF. Huh. Okay. We got two y's, and we got two quantities that are identical. So you might want to think, that looks jacked up to me, but what if it were something like this? What if it looked like that? How would you factor that? Seriously, how would you factor that? Well, you'd factor out the GCF, and the GCF would be what, folks? Y to the fourth, Z to the third, right? Times what gives you that term? What? 1, there we go. Plus who? Y, Z. Oh, that's totally doable, right? All right, so now we're going to apply the easy stuff to that. So what's our GCF? Question. When I look at the parentheses at the very beginning, it like messes with me. And I'm going, what the crap? How can I make this easier on myself? So then I say, okay, let's pretend that the parentheses weren't there. And I'm saying I recognize that they match each other, right? So I say, okay, if they match, then I'm just going to assign some random variable, and I chose Z. And I said, let me see what it looks like if I just put, instead of a parentheses, just put a Z in there. And then I look at it and I go, oh, well, that's just factoring out to GCF. So it's literally, this is a think box for me to know how to help me. It's kind of like a roadmap to help me figure out where I need to go next, okay? So do you agree with me that there's a GCF we can pull out of there? This is going to be weird, folks, but it'd be a whole lot weirder if I distribute and multiply. It'd make you want to cry. Did anybody do that? Marie, did you do that? Did you get the answer? Okay. Because didn't it cover the whole width of your page? Yeah, okay. Somebody else, I saw their paper this morning. What's the GCF of the y to the fourth things? Just for this piece right here, just the plain old y's. What's the GCF? Y to the fourth, right? You guys agree with that? What about for the quantities? It's going to be this. What's it going to be? Y plus 2, the quantity raised to the third power. I know it looks weird. This is something you've never seen before, but this is also an advanced math class, okay? It's not supposed to be something you've seen before. Bear with me. This thing, for lack of a better word, times what will give you y to the fourth quantity y plus 2 raised to the third power? 1, because we just did it up here. Plus, how many y's do we need here to get y to the fifth? I need y to the first. How many quantities do I need here to give me the quantity to the fourth? I need 1. Do I have to put 1 as the exponent? I don't need to put that, okay? Now, keep looking at it. Stare and compare. What do you think I'm going to do next? Distribute what? Be more specific. Work from the inside out. So we need to take care of this right here, Jansen. You're exactly right. Y to the fourth. Just copying that down. Plus, y times y is y squared. Y times 2 is 2y. Anybody have a desire to change something? What do I need to change? Because, look up here in my think box. When I'm factoring out that GCF, my GCF is that number. It is that term. That term times 1 gives me that term. Same thing here, Christian. this thing times 1 gives me the same thing. The first term of my problem happens to be my GCF. So my placeholder has to be a 1 and not a 0. Okay? Good question. Anybody bothered by anything you see in the brackets? Say it again. How do you know? Can it be factored the way I have it written right now? 1 plus y squared plus 2y. What do I need to do to it first before I factor it? I got to switch it around. I got to put it in what kind of order, y'all? Don't I have to put it in descending order? Okay. Now what am I going to do to that trinomial? Now factor it. Keep bringing down all this mess at the front. What are 2 factors of 1 that when you add give you 2? 1 and 1. Are my signs the same or different? Both going to be pluses. Is there any way to clean this thing up? Put that thing squared. So keep bringing down y to the 4th, y plus 2 quantity to the 3rd, times y plus 1 raised to the 2nd power. Oh my Lord, have mercy. I feel like I've just run a marathon. Not really. I'll be on the floor. We think. Does anybody have any ideas on this one? Because I did it 2 ways. Zach, you want to distribute everything first? All right, we can do that. Here we go. So n times x is nx. N times negative y is negative ny. Y'all cool with that? Facile. Facile. What's up with that right there, Zachariah? Foil it out. Really? Do I have to? Yeah. If you started it this way, you got to factor this out. Or foil it out, rather. N times y is ny. N times negative x is negative nx. Negative 1 times y is negative y. What's negative 1 times negative x? Positive x. Oh, Lord. Did I have to put the parentheses up there? No, I didn't need them. I didn't need them. What can I do? What do I do now? I'm going to just rewrite it. Y'all don't have to rewrite it. What now? Combine like terms. Huh. All right, so I've got an nx minus nx. That's good. Oh, I got a negative ny plus ny. That's nice. And then I got a plain old negative y and a plain old x. Folks, what's my answer? I could have negative y plus x or x minus y. Why would somebody do that? That one's easy. That ended up being easy, I thought. Did anybody do this a different way? I could. All right. Numero deuce. Deuce. Well, deuce is 2, too. Here we go. What was it? And the reason I'm going to show you this, I want you to become familiar with, especially with us getting ready to go into rational expressions, when you factor out negative 1. Does anything look similar up there? The x minus y and y minus x. Don't they look similar? It's the same letters. They're subtracted. Come on, right? How do I make y minus x the same thing as x minus y? By factoring out a negative 1, okay? Factoring out a negative 1. Watch this. The front part stays the same. And I don't care whether you write this down. Most of you aren't writing anything down, so. Factor out a negative 1. Okay, let's think. Negative 1 times. Negative 1 times what gives you positive y? Negative y. Negative 1 times what gives you negative x? Plus x. Do you guys see what I'm doing? It's like I'm distributing backwards, right? Is everybody with me? Your silence tells me this is what I'm getting. I say, does everybody understand? No movement in your head does not tell me, no, crap. Don't. Give me at least a head nod. Or, got it. Like even that much of a head nod. Yeah. Eyebrows. Give me an eyebrow lift or something. I don't care. Throw something. Just give me some response, please. Okay. I am not having any fun. This class sucks. All right. I am recording this. This will be the only video y'all watch. I'll have 35 views because the teacher said this class sucked. All right. That bothers me. Does it bother anybody else? It bothers me. I got to rewrite it. Why can I rewrite it? What property? Come on, come on, come on. Commutative of addition. There we go. All right, now, looky, looky, looky. What do we have going on here? What do we have going on here? Again, the funky GCF thing. Watch. Don't I have a GCF of a quantity? And now I'm going to throw it out front. This is just a grouping problem. Oh, that leaves me with, not going to factor that out yet. I'm going to do something else first. This right here, I don't know why that's shaky. I'm going to distribute this first, okay? That's going to give me, thank you, can't think. Crap, can't write either. Negative n plus 1 times that. Y'all with me? All I did was just distributed the part that I underlined with a squiggle mark. That right there. Now, GCF. Throw it out front. And what am I left with? I'm left with n plus negative n plus 1. Right? And look at that second parentheses, that second set. What's going on there, y'all? My n's will cancel out, and I'm left with x minus y times 1, which is x minus y. What was the answer? Do you see how there's more than one way to skin a cat? That's kind of cool. It is kind of cool. How could a math teacher ever force you into doing their problem their way and their only their way? Oh, can't do that. I can't do that. Because there's different ways to solve these, folks. Or maybe this is when you're supposed to see that. Questions at all? None? All right, so what's the plan for the week? This week. Today, you're going to continue reviewing factoring, and we're done. Okay? I'm going to give you a little something, something. Tomorrow, you're going to have a little something, something. The little something, something you get today, we will review it, and you will know if you understand this or not. Okay? But tomorrow's little something, something is when I find out officially if you know it or not. So what's that mean? What? No, it won't be. What's the little something, something you're going to get tomorrow, folks? Come on. You're going to have a quick quiz, and it is going to be a quick quiz. When I say quick quiz, that means 5 problems or less. And that's to be done in like no more than 30 minutes. 20 to 30 minutes is what we've got to shoot for, okay? And I hate to do that, and I usually don't ever, I hate to tell you, Kaylee, give me your paper. Kaylee, hurry. Everybody else is finished. Kaylee, come on, give me your paper. Hey, Kaylee, I need your paper. I would never do that, but the SAT is timed, y'all. I believe, is the ACT timed as well? We've got to get back into the land of sucking it up. doing our job within a time frame, okay? So, tomorrow, very quick, short, you either got it or you don't, and then we're moving on to rational expressions, okay? Which means fractions. What's a fraction? All right, you ready? Questions at all? Quiz tomorrow, right on? Thank you. All right, look at that problem right there. Look at that. What in the world? I just saw it. Look at that problem. See, I have to stand back here so I can see the forest. They cancel out immediately. Tyler, do you have to factor anything for that? What a dumb problem. I did all the work too until just now when I wrote the problem. Folks, if I had my little think box, what is x squared minus x squared? Do you see me rolling my eyes? Isn't that, oh, that is sneaky. That's a sneaky problem. Now, how many of you did factor it out? Because I did. So let's factor it out and see how we indeed get 0. I know that this is one of those souped up difference of squares problems, right? Okay? So here we go. I know that the first thing's going to be j plus k, j plus k. The second piece, j plus k, j plus k. My signs are going to be different. Plus, minus. So, add like terms. J plus j, k plus k. Folks, what's j plus j? 2j. What's k plus k? 2k. And then, I have to rewrite this. J plus k minus j minus k. That is such a sneaky little problem. Sneaky. J minus j, k minus k. What do we have? It all cancels out, doesn't it? What's anything times 0? 0. Sadie's in the 3rd grade, right? My daughter. And she's all excited because she said, Mama, we're finally learning times tables. Yeah. I said, yes. Woo! I said, which ones are you doing? She said, we're doing our 1s and our 0s. I said, okay. 417 times 1. She go, 417. I said, atta girl. I said, 3 times 0. She would go, 0. And I said, 14 times 0, 0. 382 times 0. Well, 0. Cow times 0. She went, Mama, you cannot multiply 0 to an animal. I said, hold up. If you understand the concept of multiplying by 0, it doesn't matter what anything multiplied to 0 is 0. But she looked at me, Mama, you cannot multiply a cow times 0. We just did that yesterday. All right, what's the others? 4? 4. Let's look at 4. What's the first thing we factor out? If possible. GCF. What's a GCF of 75, 90, and 27? 3. Here we go. Don't talk. 3 times. 25a squared minus 30a plus 9. Folks, you got to be able at this point to look at that trinomial and say, I got a perfect square in the front, 25a squared. I got a perfect square at the end, and my signs are going to be different. So it means I'm going to have a quantity times itself. You've got to be able to look at that. Bring down your 3. I did not slide and divide on this because I know 25a squared, what's the square root of that? 5a and 5a. What's the square root of 9? 3 and 3. My signs are the same. They're both going to be minuses. Now look, check it. Just like you did in Algebra 1. 5a times 3, that's negative 15a. Negative 3 times 5a is negative 15a, which is negative 30a. I know my middle terms match. How can I clean that up? 3 times 5a minus 3, quantity squared. Can you slide and divide on that problem? Of course you can. But why? Recognize things. You've got to condition yourself to do that. Okay? Questions on this one? What was the last one? 9? 9. Let's go over 9. Here we go. Same thing. What's the first thing you factor out if possible? GCF. What's the GCF of this? What's the first number you should check to see if it's the GCF? Shh, listen. It's up here. Psst. It's up here. What is it? I'm sorry. 8. Check the 8. See if 8 will go into 216. And by George, it will. 8 times what's 216? 27. And then what do we have right here, y'all? What is that? Difference of whose? Cubes, thank you. Bring down your 8. Remember, on difference or sum of cubes, you've got to know that it's a binomial times a trinomial. What is the cube root of x cubed? X. What is the cube root of 27? Y'all, that's why y'all talking to me. It's very good. Oh, if y'all want to play that game, we can play that game. When you talk to me like this, but when you speak to me like this, I will speak to you like this. Don't be fart faces. Now, we've got to get the middle term. How do I get the middle term? 3 times x is? That sounded like a song. 3 times x is 3x. What about the signs? Oh, look. That's right. Minus, plus, plus. Is that it? Can I factor that 3x plus 9 thing? No, that's it. That's all she wrote right there. Questions? Comments? Nothing? What are you going to do? You're going to study this, and you're going to study those homework problems that you did or did not do. Folks, I'm telling you, you better study your homework problems because your quiz is not going to be this easy. It's going to be all about some GCFs, so you better factor those out. Seniors, get out of here if you have first lunch. And if you don't, just stay here with us.